Alright, today was a long day. I really planned to, I was planning to record today is the 13th day. I was planning to record the recap much more earlier, but I wasn't able to get home um, early because there was a train delayed. I was in a hackathon. I was gonna say that, yeah, this day I programmed a lot. We developed a bot that it's able to, yeah, let me show. I cannot show all the functionality because in the end I made some changes. We were not able to present all of it, but basically the bot was called Meeting Mind, and the idea was that it was able to enter to some meeting and be able to participate in the conversation and to be able to answer questions, interrupt, etc., etc. And that's it. And another thing that I did was study because I have an exam on Monday, and I can show. It was about, I think it's about this, about uncertainty reasoning. The first things I basically just studied the beginning of it. Just a quick recap of the frequencies, the Bayesians, and a little bit of the IDM, the imprecise Dirichlet model. And everything can be, at least of the beginning, can be understood. I can say a couple of things. First, that there is a problem, at least for uncertainty, of how frequentists understand probabilities, because they can assign the same probabilities even to cases that seems completely different. For example, if you have a small sample, you assign 50-50 when you flip a coin, and you also assign the same probability when you have a larger sample. But the Bayesian probability, because you start with a prior, in a sense we understand that the variance is very small. I'm sorry, like for a small sample the variance is very big. So we are not, we have to have a tool in which we can say we don't know exactly. And there is an issue with this. I don't know, in naive bias, for example, if an observation has not happened, we assign probability 0, and that's a problem because in test, like if that happened in training, then in testing you will never predict this, and you don't want this, because the fact that it didn't happen in the training set, it doesn't mean that there is no probability of it happening. All right, so you have the Bayesian way of understanding it, which in essence is just the prior over a beta distribution. And all of these different names and different papers are different parameters of a beta with different prior. That's the only thing. For example, of a beta of 0,0 is this, of a different beta it's the other ones, and computing it is just substituting values in the beta formula. And what else? In the indirect Dirichlet model is just about computing expectations. The lower expectation, the higher expectation based on this, and that's about it.